So for our topic for today is the chapter 12 of the Philippine Mechanical Engineering Code, which is metrology. So metrology is the science of measurement. It includes all theoretical and practical aspect of measurement. So first I will introduce our team. So we have Steven John Stelia, Jason Dave Flores, Denver Siniberas, Arvin Jola Rakedan, and Christopher John Rivera. So the purpose and scope of our study is to familiarize all practitioners with the concepts and techniques of measuring instruments. It covers the application of metrology in all industries, which concerns with the fundamental standards and techniques of measurements and with the scientific principle of the instrumentation involved. So for our topic for today, we have definitions, measurement concepts, classifications of the common measuring instruments used in industry, graduated manual measuring tools, non-graduated manual measuring tools, special purpose measuring tools, non-destructive inspection, pressure and vacuum measurements, thermometry and pyrometry, flow metering, measurement of weight, the three common methods of rational speed measurements, and the environmental and pollution measurements. So first, the definitions. So this will we will define some important terms which will help us to understand deeply, or which will help us to understand the discussion as we go on. So first is correctness and accuracy. So correctness and accuracy is the degree of conformity of a measured or calculated value to some recognized standards or specific value. So next we have the precision. So it is the repeatability of the measuring process or how well identically performed measurement agree which concept applies to a set of measurement. So a picture here will show you the difference between the accuracy and precision. So accuracy, it talks about how close a measured values are to each other. So as you can see on the lower left figure, we can see we can see a precise marks, but it's not accurate. So it only talks about how close measured values are to each other. While you can see in the uh, upper right, we have a accurate but not precise. So accurate is how close a measured value is to the true value. So you can see the marks are located where the bullseye is located. So on the lower left, we can see an accurate and precise measurement. So tolerance is the amount of variation permitted in the part of total variation allowed in a given dimension. Here, tolerance is the limit. So it states the acceptable measurement ranges. Allowance is the minimum clearance space intended between the mating parts and represents the conditions of tightest possible fit. So when we say allowance, it is the intentional difference of the maximum shaft size and the minimum hole size. So when we say intentional difference, it is designed. So it is the prescribed difference. While the tolerance is the permissible variation. So it is the difference between the lower and higher limits of dimension parts. Standard. So standard is something that is set up and established by authority as a rule for the measure of quantity, weight, extent, value, or quality. So it is the set of technical definitions and guidelines and how to instruction for designers, manufacturers, and the users. So next, sensitivity. So it's the ability of a measuring device to detect the small differences or the smallest absolute amount. Readability is the susceptibility of a measuring device to having its indication converted to a meaningful number. So it indicates the closeness with which the scale of the instrument may be read. So next, we have the measurement concept. So I know some of us are familiar with the International System Units or the SI units. So what is the SI units? So SI units is considered the modern form of the metric system. So it is the most widely used system of measurement in the world based on the 4 MKSA units, or the meter, kilogram, second, ampere. So it is the most of the industrially advanced metric using countries are changing from their traditional metric system to SI. So International System of Units, or SI, is based on decimal arithmetic. So the SI is like the traditional metric system. For each physical quantity, units of different size are formed by multiplying or dividing a single base value by powers of 10. So next, it is a coherent system. Why? Because the product or quotient of any two units quantities in the system is the unit of the resultant quantity. So for example, in a coherent system, in which the meter is the unit of length and the square meter is the unit of area. So next, we have the mechanics. So there are 6 basic base units, which are the length. So it is measured in meter, or has a unit of meter and a symbol of m. And mass has a unit of kilograms, has a symbol of kg. Time in seconds, denoted in symbol S. The electric current, or the ampere, has a symbol of A. The thermodynamic temperature, or the absolute temperature, it is has a unit of Kelvin, denoted in the symbol of capital letter K. And the luminous intensity, candela, or has a symbol of CD. So there are also some other physical quantities derived from the base units, which is the velocity. So velocity is meters per second. So it is the length over time. The acceleration is the derivative of the velocity. So it has a unit of meters per second squared. So the force is measured in Newton. So Newton is kilogram meter squared per second squared. So next is the energy, joules, measured in joules, as a unit of a symbol of J. So power, we also have power. So it is has a unit of joules per second. So joules per second is equivalent to watts, or capital letter W. So we have the mass, weight, force, and load. So mass is the measure of the body's inertia. Weight is the force exerted on the body by gravity. So the formula for weight is mass times gravity. Another thing about mass is that mass is absolute. Your mass here on Earth will be your mass in the moon, or when you go to the moon. But it will only differ if you talk about the weight, because the gravity here on Earth is different from the gravity in the moon. So next, force. Force is proportional to the mass times acceleration. So next, we also have stress and pressure. So both are expressed in terms of force per unit area. So the formula for pressure and stress is force over area. Next, we have the classification of the common measuring instruments used in the industry. So here, we have the linear measurements. We have under this, we have the direct reading. So first is the rule, combination set, depth gauge, vernier caliper, micrometer, measuring machine. It can be a mechanical or optical. So this will be discussed later, and it will be the definitions and uses will be given. So another classification is for the instruments for transferring measurements. So we have the calipers and dividers and the telescopic gauges. Next, we have the angular measurements, which are the protractors, sine bar, combination set, angle gauge blocks, and dividing head. We also have plane surface measurement. Under this, we have the level, combination set, surface gauge, profilometer, and optical flat. We also have all-purpose special measurement. We have pneumatic, hydraulic, electric or electronics, lasers, and others.
I will be discussing what is graduated manual measuring tools. Graduated measuring tools are tools with a set of markings, or these are the graduations, on a linear or angular scale to which the object's feature of interest can be compared for measurement. For short, first example of the graduated manual measuring tools are rules. They are the most generally used graduated measuring instrument in the industrial metrology field for approximately determining linear dimensions, which are made with various dimensions, graduations, and accuracies. So basically, rules are for measuring linear dimensions, such as width, height, or depth. An example of under the rules are there are three. So there are shrink rules, hook rule, and tapered rules. For shrink rules, they are commonly employed in the pattern making trade, where the casting of metals are involved, which are automatically take into consideration the shrink allowances of the materials being cast. So for short, yung mga shrink rules, parang ruler din sila, pero may konting adjustment. For example, yung shrink rule para sa iron, instead na regular na 1 inch, nag-increase siya ng 1/8 inch para sa allowances. Kasi may times na nag-shrink sila due to external forces. Next slide. Hook rule, frequently used to assure the user that the end of the workpiece is flush with the end of the rod. So, ito naman, it is a ruler na may parang holder sa hulihan. So basically, ito yung ginagamit sa kapag kunwari mag-measure tayo ng isang square board. Instead of using a ruler na may inaccuracy kapag piniplace sa end, we are going to use a hook rule because yung feature nito is yung may pa-flush sa end, which is more accurate than using a ruler. For tapered rules, it is used in measuring inside of small holes, narrow slots, and grooves. So ito naman, it is a ruler pero yung width niya is small to palaki, which means yung small part pwede siyang ipasok sa kunwari sa isang butas para i-measure yung kung gaano ka-depth. Ganon. So another example of graduated manual measuring tool is calipers. So there are three example of calipers or under the calipers. First is the slide calipers, which consists of a stationary integral with graduated beam on which then movable jaws slides with a reference point for inside and outside reading. So itong type ng caliper na to is basically straightforward, which is gagamitin mo to for measuring the outside and inside diameter. Kung anong makikita mo sa slide caliper na measurement is yun na mismo. Wala nang multipliers na i-consider. For vernier calipers, it is a measuring instrument which can be used for taking both inside and outside dimensions and even the height of an object with accuracy. So, ito namang vernier caliper. Sa kasasabi ko lang kanina, sa slide caliper, straightforward siya kasi kung anong makikita mong measurement doon is yun na. Compared to this vernier caliper naman, ganun din siya. Kung anong makikita mo, yun ang measurement. Pero, merong tinatawag na vernier scale. So, after mo makita yung obvious na measurement, is may i-add ka pa. Tapos may multipliers na i-consider. Yung vernier scale na yun ay magko-compensate sa human estimation error. The last type of caliper is the dial caliper. It is directly reading calipers which are accurate up to the thousandth of a centimeter. Ito naman, ito na ang pinaka-straightforward sa tatlo. Kasi, same usage din sa slide and vernier. Pero, ang difference nito is may dial indicator siya. So, pag ginamit mo to, titignan mo lang yung parang analog clock. And makikita mo na doon yung kung anong measurement na mini-measure. Vernier height gauges are used in inspection departments or whatever layout and jig and fixtures works necessitate accurately measuring or markings of vertical distances. So under this there are two, vernier depth gauges and gear tooth vernier calipers. For vernier depth gauges, they provide long-range accuracy for determining the depths of holes, slots, and recesses, as well as measuring from a plane surface to tool maker's buttons in locating center distances. So, may vernier na naman. So, gumagamit na naman siya ng vernier scale for compensating the human estimation error. Pero ito naman, instead ng diameter, ang mini-measure niya is depth. Or, for example, kung gaano ka lalim ang isang hole. The gear tooth vernier calipers. So basically, it is used to check the pitch line thickness of gear teeth by measuring the tooth cord at a specific distance from the top of the gear tooth. So ito naman, meron siyang dalawang purpose. Kasi may kita sa picture, meron siyang horizontal at vertical na vernier din. Yung horizontal na vernier at the picture is measures the cordal thickness of the gear or kung gaano ka thick yung gear. While the vertical naman is it measures the cordal addendum. So basically dalawa yung purpose ng vernier height gauges. So another example of the graduated measuring tool is the micrometer calipers. So ito naman, they are most useful close tolerance measuring devices for quick and accurate measurements to the 1,000th part of a centimeter. So marami siyang types which are outside, direct reading, blade type, quick adjusting, screw thread, and inside micrometers. For outside micrometer, so basically ito ay micrometer na nagme-measure ng outside diameter. So marami siyang types which are interchangeable anvil micrometers, multiple anvil micrometers, high precision, and marami pang iba. Direct reading micrometers are read directly in thousands from figures appearing in small windows on the micrometer. Tenths. Direct reading micrometers, however, employ a vernier for establishing the tenths figures. Another type of micrometer caliper is the blade type micrometers, which are an adaptation of standard micrometers in which the anvil and spindle ends are pinned to a blade shape, which are used for checking the root diameter of circular form tools as well as diameter of circular form tools, such as slots, keyways, recesses, etc. So ito ay micrometer naman. Pero yung anvil is yung nasa taas, which is nag-hold sa taas ng object na mini-measure. So, tapos yung spindle ends naman is yung nasa kabila. So basically, para din siyang outside micrometer pero naka-blade form yung end-to-end niya para mag-measure ng mga circular or ring objects for their outside diameter. Quick adjusting micrometer. It allows the spindle to be slid quickly to any point within range, which makes them particularly efficient thousands reading micrometers for checking work where a variety of dimensions are. Ito naman, kasi yung mga micrometers, pinipihit yan para mag-adjust. Pero ito, quick adjusting micrometers, may push and pull mechanism siya para mas mabilis yung pag-measure. Kumbaga kailangan ng quick data gathering. So it is advisable to use quick adjusting micrometers. Another example of micrometer calipers. Screw micrometers are designed to measure the pitch diameter of a screw, which thousands accuracy by the use of a pointed spindle and double V anvil, which are available for varying diameters of fork, and each size normally covers a range of threads per centimeter. So ito naman is specialized siya sa pag-measure ng pitch diameter ng screw. So as opposed to outside micrometer, ito namang inside micrometer basically is nagme-measure sa ng inside diameter or nag-measure yung mga holes or basta nag-require na mag-measure ng inside diameter protractor, which consists of rectangular head graduated in degrees along a semicircle with the blade pivoted in center plane. Any angle from 0 to 180 degree can be set. So may dalawang klase siya, which is combination protractor and depth gauge and universal bevel protractor. For the first type of protractor, it is the combination protractor and depth gauge. So basically, combination sa ng protractor at yung pang-measure ng depth. Another example is the universal bevel protractor. Consists of a round body with a fixed blade on which graduated to reticulate. So basically, angle din yung mini-measure nito. At the topmost where the reading of the measurement will occur, may vernier scale din siya. Dial indicator, which is composed of graduated dial, spindles, pointers, and a satisfactory means of supporting or clamping a turn, which is used to measuring accuracies, alignment, centricity, and deviations on surfaces supposed to be parallel. So under this dial indicator is the dial test indicator. So commonly known as the toolmaker indicators, which are smaller than smallest American gauge design standard indicator, and because of its small size and its thin tapered body, can be employed in many places not accessible with other indicators, also used as an accessory with many machine tools. Graduated measuring tool is the planimeter, which is a tool for checking the flatness of plane surfaces to tens of thousands of centimeters and consists of a die-based straight edge and an adjustable mounting for the straight edge and a 0.0005 centimeter reading indicator. So basically, yung planimeter naman or tinatawag ding pencator, nag-check din siya ng flatness ng isang surface. So, kung may graduated manual measuring tools, meron namang non-graduated manual measuring tools. So, they are tools used to make comparisons between dimensions or to transfer a dimension for measurement. They are graduated measuring tools. So, ito naman, hindi siya nagme-measure ng, hindi siya nagbibigay ng measurement. Or rather, nagtatransfer siya ng dimension. So, first type of the non-graduated cylinder are the calipers, which follows a progression which originates and standard inside and outside calipers and are non-graduated tools for measuring the distance between 2 points of contact on the workpiece. So, ito namang calipers, kung makikita niyo sa picture is wala siyang measurement. So, pwede siyang pang-measure ng object length or width, for example. Dun sa right, parang outside width or anything that can be measured by length. Pwede mo siyang i-move, pwede mo siyang gamitin, mag-move ng dimensions kung saan mo paggagamitan yung measurement. And on the other hand, the caliper on the left, parang hole naman siya. So basically, pwede mo siyang mag-transfer ng whole measurement. And the next type is the bevels, which consists of 2 3 non-graduated slatted blades with one or two screws nerve knocks connect to them. By loosening the nuts and blades can be set varying angles. So ito naman, kung makikita nyo, wala rin siyang graduated na markings. So ang ginagawa niya rin ito, as compared to calipers na length yung tinatransfer niyang measurement, ito naman is angle. So next type is the trammels, which use incisors beyond the range of dividers. Consists of a long bar on each two arms or trammels slide. Trammels are designed for layout work and use inside, outside, or divider legs, and some are furnished with ball points to permit working from holes. So ito naman, before discussing the trammels, meron tayong tinatawag na divider, which is basically a protractor. No, not protractor. It's a compass. Pero wala siyang pang mark. Both pointed ends lang. So kapag hindi may certain angle na hindi ma-reach ng divider, trammels yung ginagamit. As mayroon siyang straight long bar. So mas wide yung pwede niyang transfer na length. A gauge is a device used to determine whether the part has been made to the tolerance required and does not usually indicate a specific dimension. So ito ring gauge na to is may dalawa siyang types. First is the telescoping gauges. Covers a range from 4 mm to 150 mm. Two types are commonly used in industry. One type has a handle with one stationary contact and one spring plunger contact with locking device set at right angles to the handles, while the other one has a handle with two plunger contacts at the right angles to the handle. So ito naman, ginagamit din siya sa pag-transfer ng measurement, pero more on holes. Surface gauges, which consists of round rectangular steel base with a round upright rod and a fine adjustment feature in the base. So ito naman, madalas siyang makikita sa mga machine shop. Pero yung purpose nito is para mag-describe ng lines, either vertical or horizontal. And ginagamit din siya sa inspection work as height per depth gauge, straight edges. So basically, it is a ruler without graduations para mag-describe ng accurate straight lines. So next type of measuring tools are the special purpose measuring tools. So ito naman yung mga measuring tools na create para sa isang specific application. So the first type is the tap and drill gauges, which consists of a flat rectangle of steel with holes accurately drilled and identified according to their size. Next is the wire gauges. They are round steel plates with slats of ascending width along their edge. Each hole is numbered according to its size in terms of wire standard gauges. So ito naman, para din siyang tap and drill gauges. For example, wire. May measurements na gauge 5 or gauge 5. So, yung gauge 5 na yun, pwede mo siyang gamitin on either which application na paggagamitan mo sa pinagmulan mo ng measurement na yun. Screw pitch gauges consist of a metal case containing many separate leaves. Each leaf has teeth corresponding to a definite pitch. So, ito naman, yung application ito is for screw or specifically the pitch is the radius gauges. They are individual leads or a set of leads in a case and are designed to check both convex and concave radii. So ito naman, ginagamit naman to sa pag-transfer ng measurement ng mga curved surface or anything that is circular in shape. So yung makikita sa picture, meron tayong tinatawag na convex and concave radii. So yung sa left, convex radii yung parang ginigauge niya. While on the right, concave radii naman. Lastly, for the special type is the thickness or pillar gauge, which consists of a number of thin blades of different thickness and used in checking clearances, backlash in gears, and for gauging in narrow points or places. So ito naman, ginagamit siya. Yung gamit niya is parang gumagamit ka ng kutsilyo. Ito yung nag-gauge sa distances ng dalawang objects. For example,
So for the non-destructive inspection, this is a testing and analysis techniques used by industry to evaluate the properties of materials without causing any damage to the test objects. And there are 6 testing methods analysis that I will discuss. First is the hardness measurement. In determining the hardness of mild steel and non-ferrous alloy, a penetration hardness tester is utilized and mostly semi-portable. Second, magnetic particle inspection. In this type of inspection, cracks, voids, and material discontinuity can be detected through the settings up to intense magnetic field in the part to be inspected. This method is used to indicate surface imperfection in any materials that can be magnetized. Next is the radiographic inspection. This is accomplished by exposing a part to either gamma rays, X-rays, and reduced isotopes and viewing the image created by radiation of fluoroscope or film. Next is the fluorescent penetrants. These are used to find surface defects in almost any materials. Next is the ultrasonic testing. In ultrasonic testing, a high-frequency vibration or supra-audible signal is directed into the part to be tested to determine the metal thickness precisely. And lastly, eddy current testing. This method is used for flow detection, sorting by metallurgical properties such as hardness and thickness measurement. The change of magnitude phase difference can be used to sort part according to alloy temper and other metallurgical properties. Pressure and vacuum measurement. Pressure measurement by balancing an unknown pressure against a known force is the simplest and oldest method that will automatically balance the static pressure being measured against the resisting force whose magnitude can be read directly from the instrument or can be easily computed, such as liquid column gauge, limp diaphragm gauge, bell-type gauge, piston gauge. Pressure measurement by deforming or elastic membrane. This is the most universally used for measuring high and medium pressure because of its simplicity, compactness, and maintenance-free properly. It is also widely used in the field of low pressure measurement where a large actuating force is not needed. Example of them is Bourdon tube gauge, helical type of pressure gauge, spiral type of element in Bourdon type of pressure gauge, metallic diaphragm pressure gauge, sector gear arrangement, cam and roller arrangement. Electromechanical pressure instruments usually employ a mechanical means for detecting the pressure, and the electrical means for indicating or recording the detected pressure. There are combination of mechanical bellows, metallic diaphragm, or Bourdon tubes with electrical sensing indicating recording, or transmitting the device employing pressure transducer, induct transducer, and oscillating transducer. Normally depends on some physical change that can detected or indicate or recorded electronically. Vacuum gauge, mechanical, electrical, and electronics. The pressure gauge used primarily for measuring pressure below atmospheric pressure, which is most often referred to as vacuum. And here is the subtopic: Macleod gauge, Pirani gauge, Knudsen type vacuum gauge, Philip vacuum gauge, and vacuum gauge calibration.
So let's move on to the next topic, which is the thermometry and pyrometry. So next slide, please. So first one is indicating and recording thermometer. Pressure actuated instrument that uses the energy available in the form of increased pressure or volume, a substance to indicate and record the change in temperature that liberated this energy. Next. Proper location of an indicating and recording thermometer. So first one is the thermometer bulb shall be located in such a way as to permit the recorder to be removed for repair. Second is the recorder shall have enough tubing to permit the bulb to reach a convenient location for the test pad. Next. So third one is the thermometer tubing shall be properly fastened and out of the way of damage from operators, mechanics, and pipe fitters who may have occasion to work near the installation. Fourth, the angle of the tube at the neck of the bulb shall be protected. Next one. So fifth, the tubing shall never be in contact with hot steam pipes or stocks, which would increase the chance of ambient temperature errors. Lastly, the location of bimetallic recording thermometers shall be carefully checked for dirt and dust in the air. Next. Next. Next, please. So the specification, the selection of thermocouple materials. So first one is should produce a large electromotive force that varies linearly with temperature. Second, shall be corrosion and oxidation resistant, shall be resistant to change in characteristics that shall affect their calibration, and shall be free from parasitic currents. Required reading shall be reproducible within the accuracy limit, shall be physically strong enough to withstand high temperature, rapid temperature changes. Again, these are the specifications in the selection of thermocouple materials. So next one. So these are the temperature limitations in the selection of the thermocouple materials, or these are the best temperatures for these materials. So copper constantan, 185 to 300 degrees Celsius. Okay, let's move back. Okay, so iron constantan 18 to 760 degrees Celsius. Chromel alumel up to 1320 degrees Celsius. Platinum rhodium 700 to 15 degrees Celsius. So next one. Proper installation of thermocouples shall not be located in direct path of a flame. Okay, yun naman ay basic. Shall be located where the very average temperature is measured. Shall be located where the hot end can be seen from a door of the furnace. Shall be immersed in the furnace or vessel far enough so that the junction is entirely in the temperature to be measured. Next. So another proper installation shall be partially immersed on order to keep it cool. A support shall be provided to prevent sagging. Shall be installed in a pocket to prevent damage from material in the furnace. A porcelain tube shall never be inserted in a hot furnace. So next one. So important considerations in writing thermocouple. So the first one is play. Conduct shall be used and thermocouple head shall be connected directly with a flexible cable. All wires that must be spliced shall be soldered no less than 3.31 millimeters squared copper wire shall be used. And another one bites the dust. Next. So wire shall never run parallel to or cross within 30 centimeters any AC line of 110 volts or more. Take note of that. Okay. So surge lightning arresters shall be used where there is danger from the source. Okay, danger. Next one. So rotary switches used for connecting the thermocouples to the indicating instrument shall be very rugged to withstand the temperature to be measured. So next one. So types of temperature measuring instrument. So the resistance thermometers in which the resistance of a calibrated wire changes with the temperature, the resistance change being proportional to the increase in temperature. So resistant thermometers. So a resistant thermometer is basically an instrument for measuring electrical resistance, which has been calibrated to read in degrees of temperature instead of units of resistance. So yun yung pinagkaiba niya sa ibang thermometers. So thermistors, which are thermally sensitive resistors, are electronic semiconductors whose electrical resistance varies with the temperature and are useful industrially for the automatic detection, measurement, and control of physical energy. So next one. So the characteristics of resistant thermometers or thermistors. So first one is frames are capable of withstanding the temperature. So high sensitivity of measurement din siya. Tapos yung metals niya is used for high degree of linearity over the resistance temperature range. Okay, next. So meron din siyang resistance na 40 to 500 degrees Celsius temperature range. Tapos, pwede rin siyang gamitin within the negative 80 to 400 degrees Celsius temperature range. Okay, next. So types of temperature measuring instruments. So ito na yung mga liquid filled glass thermometers in which there is an expansion or contraction of a liquid corresponding to the changes in the temperature, the expansion of the liquid being proportional to the increase in temperature. Okay, next one. So may mga requirements din to. So ito yung first one is the vapor pressure shall be negligible or hindi na i-consider over the temperature range for which it is to be used. The coefficient of cubical expansion shall be high. So mataas dapat. Okay, next. The liquid shall have a low specific gravity, a low specific heat, and high coefficient of heat conductivity. The liquid shall be incompressible. Okay, next. So, ito pa yung mga other requirements. So, the thermometer shall be installed properly. So, very common sense. The temperature sensitivity bulb shall also be properly immersed in and physically contact with the medium to the medium. So, medium to medium. Okay, yun. The thermometer shall be installed at the point of maximum flow. Okay, next, body. Okay, types of temperature measuring instruments. So letter D, Bourdon tube thermometers, which operate by the expansion of a fluid as follows. So ito yung mga parang yung specs niya, yung mga features niya, kumbaga. Expansion of liquid that completely fills the enclosed tubing and valve of the instrument. Expansions of the liquid in the valve of the instrument. Expansion of gas that completely fills the tubing and valves of the instrument. So yan, next one. So meron din siyang mga classification. So class 1, liquid filled tank. So alam na basic na liquid. Class 2, partly filled with liquid. Class 3, filled with completely with gas. So parang liquid, semi-liquid, tsaka gas. Yun yung tatlong classification niya. Okay, types of temperature measuring instrument. Radiation pyrometers in which there is a small body capable of absorbing radiation of all wavelengths. The radiation absorbed being proportional to the temperature. Proportional to the temperature. Okay. Types of, isa pa to optical pyrometers, by which the temperature is determined by matching the luminosity of the hot body of which the temperature is to be determined with the luminosity of a calibrated source of light. Okay. So ito pa, pyrometer cones by which the temperature is determined by the bending over of a graded set of ceramic cones, which having a definite heat resisting value. So take note of that. Definite heat resisting value. Okay. Next one, bimetallic thermometers depend on the differential expansion of two solids. The differential expansion being proportional to the increase in temperature. So parang kapares niya yung kanina. Proportional din siya sa temperature. Okay, ito na naman. Electronic thermometers. From the word itself, electronic. So magkaka-idea ka na ito ay electrically powered. So yun na yun. So next. Uy, flow metering na tayo. Go. So may mga classification yung flow meter. So first one is inferential type. Ito yung obtains a measurement of the flow of a fluid or gas not by measuring the volume or weight of the medium but by measuring some other phenomenon that is a function of the quantity of fluid passing through the pipe. Okay, next. So ito yung mga classification ng differential pressure meters. Isa na dyan si Venturi tube type, pangalawa si flow nozzle type, pangatlo si orifice place type, at pangapat si pitot tube type. Pasensya na kayo, wala kaming pictures dyan. Okay. So yung susunod is area meters or rotameters. Tapos anemometers. So yan, anemometers. Familiar na kayo dyan kung engineering student ka. Alam mo yan. Okay, electrical meters. So yung electrical meters, meron din siyang sub type. Okay, ito yung electrical air conductance meters, tsaka yung electromagnetic flow meter. Okay, let's move on. So ito na, dito na tayo ngayon sa volumetric and current types. So yung una is piston type, volumetric flow meter. So may mga classification na naman yan, parang dun sa una. Okay, ito na yung una, notating disc pump. Pangalawa, rotary sliding vane flow meter. Pangatlo, oscillating piston flow meter. Pangapat, rotating bucket flow meter. And lastly but not the least, screw type of flow meter. Okay, next. Marami pala. So ito pa yung susunod, spiral vane flow meter. Tsaka bellows type gas flow meter. Water sealed rotary gas meter. Roots type of volumetric gas meter. Turbine type current flow meters. So lahat sila actually may meter sa huli. Go. Sige. So ito na yung pinakahuli sa aking i-report. So yung installation ng volumetric flow meters. So all volumetric flow meters that are subjected to high head pressures should be protected by means of a bypass check valve. Bypass check valve. Always remember that. Which will relieve the pressure in case the meter should become jammed owing to foreign materials. Otherwise, excessive pressure may build up and serious damage is done. So to prevent this.
So yan, punta naman tayo sa measurement of weight. Ano ba yung weight? First, weight is a primary method of measuring force, and volumetric devices are calibrated initially by weighing. Scales have been constructed to weigh 1,000,000 kilograms or more, while the chemical balance at the opposite extreme will easily weigh 1,000,000 of a kilogram. May tatlo tayong classification of weighing scale. So mauna yung platform scale. So the common platform scale used in the laboratory consists of a compound leverage system. A series of standard weights hung on one end of the leverage system serves to balance an unknown weight at the other end of the system. So ano nga ba yung yan? So yan yung platform scale. So yung mga benefits na makukuha natin dyan, it is easy and accurate measurement, increased productivity, reducing shipment mistakes, and preventing overloading. So next. So susunod naman is yung pendulum scales. So yung pendulum scale give automatic indication on over a wide range and are extensively used when speed is important. So yan siya. So minsan tinatawag din siyang equal arm balance. So it is usually used for weighing coins, gold, silver. So ayan, sa electrical scales naman tayo. Combination of mechanical elements and electrical measuring devices. Weighing can also be accomplished by supporting the load on hydraulic pistons, diaphragms, or below units and measuring the resulting hydraulic pressure with any convenient pressure gauge. So yan yung itsura. So yung mga benefits na makukuha natin dito sa electrical scale is siya ay reliable. Digital weighing machines have appropriate platform. Mas madali siyang maintindihan. So the three common methods of rational speed measurement. So una, a common type of revolution counter wherein the rubber of steel tip is applied directly to the shaft center and friction is relied upon the drive, the spindle. Ito yung counter and timer. So tachometer gives a direct and continuous indications of speed and is therefore the most convenient for observing speed variation or fluctuation and for general observations in which a high degree of accuracy is unnecessary. So may mga type siya. Una is yung contact type. Yung contact type is nakakontact siya sa machine or usually nakafix siya sa machine or motor. Next, non-contact type, gumagamit naman siya ng infrared light, laser, at saka ano pa, as long as wala siyang physical contact sa machine. Stroboscope utilizes the phenomenon of persistence of vision when an object is viewed intermittently. So ito naman yung stroboscope, ginagamit siya to measure revolutions, velocity, frequency of rotating components or moving parts. So punta naman tayo sa environmental and pollution measurements. Humimeter, instrument to measure the relative humidity of the atmospheric air, which is important as comfort factor and is measurable of how many airborne particulates are held in suspension where we can take them into our lungs as we breathe. Hygrometer or psychrometer, instrument to measure also the relative humidity of the environment, which utilizes the physical or electrical change of certain material as they absorb moisture. It registers the temperature difference between two primary elements on which is kept wet so far water is continuously being evaporated from its surface. So ito naman yung mga i-consider natin sa paggamit ng hygrometer. So A, provision of hygrometer. So una, weaving department. One hygrometer for department with less than 500 looms and one additional hygrometer for every 500 or part of 500 looms in excess of 500. Two, other departments. One hygrometer for each room of less than 8,500 cubic meters capacity and one extra hygrometer for each 5,600 cubic meters or part thereof in excess of this. Number three, one additional hygrometer shall be provided and maintained outside each cotton spinning and weaving factory wherein artificial humidification is adopted and in a position approved by the inspection for taking hygrometer shade readings. So next na i-consider, temperature to be recorded at each hygrometer. At each hygrometer maintained, correct wet and dry bulb temperature shall recorded daily during working hours, except intervals for less by competent persons nominated by the manager. So specifications of hygrometer naman tayo. First, each hygrometer shall comprise two mercurial thermometers of wet and dry bulb of similar construction and equal in dimensions, scale, and divisionals of scale. They shall be mounted on a frame with a suitable reservoir containing water. So three, no part of wet bulb shall be within 75 millimeter from the dry bulb or less than 25 millimeter from the surface of water, and the reservoir shall be below it, on the side of it, away from the dry bulb. The bulb shall be spherical and of suitable dimensions, and shall be freely exposed on all sides to the aid of the exposed on all sides to the aid of the room. 5. The bore of the streams shall be really distinguishable at a distance of 60 centimeters. Each thermometer shall be graduated so that accurate readings may be taken between 10 to 50 degrees. 7. Every degree from 10 degrees up to 50 degrees shall be clearly marked by horizontal lines on the stem. Each 5th and 10th degree shall be marked by longer marks than the intermediate mark opposite each 5th degree. For example, 10, 15, 20, 25, 30, 35, 40, 45, and 50. The markings as above shall be accurate. That is to say, at no temperature between 10 to 50 degrees shall be indicated readings be in error by more than 2/10 of a degree. A distinctive number shall be indelibly marked upon the thermometer. The accuracy of each thermometer shall be certified by the Bureau of Standards, Ministry of Trade and Industry. So D, thermometers to be maintained in efficient order. Each thermometer shall be maintained at all times during the period of employment in efficient working order so as to give accurate indication and in particular. So first, the wick and the Muslim covering of the wet tube shall be renewed once a week. The reservoir shall be filled with water, which shall be completely renewed once a day. Or the engineer manager may direct the use of distilled water or pure rainwater in any particular mill or mills in certain localities. No water shall be applied directly to the wick or covering during the period of employment. So E, an inaccurate thermometer must not use without fresh certificate. If an engineer gives notice in writing that a thermometer is not accurate, it shall not, after 1 month from the date of such notice, be seen to be accurate unless and until it has been re-examined as prescribed and fresh certificate obtained, which certificate shall be kept attached to the humidity register. F. Hygrometer not to be fixed to wall, etc., unless protected by wood. So 1. No hygrometer shall be affixed to a wall, pillar, or other surface unless protected therefrom by wood or other non-conducting material at least 12.7 millimeter in thickness and distant at least 25.4 millimeter from the bulb of each thermometer. 2. No hygrometer shall be fixed at a height of more than 1,700 mm from the floor to the top of thermometer stem or in the direct draughts from a fan window or ventilating opening. No reading to be taken within 15 minutes renewal of water. No reading shall be taken for record on any hygrometer within 15 minutes on the renewal of water in the reservoir. H. How to introduce steam from humidification. In any room in which steam pipes are used for the introducing of steam for the purpose of artificial humidification of the air, the following provisions shall apply. First, the diameter of such pipe shall not exceed 25 mm. Such pipes shall be as short as is reasonably practicable. All hangers supporting such pipe shall be separated from the bare pipes by an efficient insulator not less than 15 millimeter in thickness. No uncovered jet from such pipes shall project more than 100 millimeter beyond the outer surface of any cover. The steam pressure shall be as low as practicable. Next, the pipe employed for the introduction of steam into the air in a department shall be effectively covered with such non-conducting material as may be approved by the engineer.
So thank you po. Diyan na po nagtatapos. At napawisan po yung kasama nating si Christopher. Pero okay lang yon. So sana may natutunan kayo sa aming munting presentasyon na may kasamang edukasyon. Dito na nagtatapos ang aming programa. Peace out.